Right. Welcome to the programming subject, students. So this is a continuation of our previous lesson. We were talking about generations of programming languages and language translators. So just little while ago, I gave you a proper recap of the session. So from this slide onwards, let's get started. So in this slide, basically we have a comparison between what is a compiler, what it does, and what is an interpreter, what it does as well. So this is what we're going to discuss in this slide, right? So if you have your inputs, if you have your doubts or questions, please feel free to talk to me while I am explaining this. All right. So if you take compiler, both these type of mechanisms are needed. If you want your source code need to be converted to machine code, then only the device or the computer can understand, it can execute. Definitely, whether it is a compiling or interpreting, doesn't matter. We need a language translator, then only the computer can understand the instructions that you are written in the human readable form. So the conversion can be done in two ways. That is the difference here. Conversion can be done in either compiling method or interpreting method. So that we have, if you are compiling, we are using a compiler. If you are interpreting, we are using an interpreter. So we're going to see the differences between them, and this can be useful in your assignments and when you're building up your notes. Right, without further delay, let's get started. So if you take compiler or compiled programs, so what it has to offer is converts the source code into machine code before execution of the program, As I told you that day, I created the Java file. In the previous recording, it is there. Java file is there, which I am building. Java file is there. I compile it. You get a new file called .class file. That is compiling. Once you compile, a new file is coming. You have a C program file called calculator.c. You compile it, you get calculator.exe executable file. C is a compile language. So once you compile it, you get a calculator.exe file. Your notepad program in your computer, it's a exe file. Your calculator program in your computer is an exe file. It has been compiled. The programming language they have used to build your calculator program, notepad program, they have used C++ programming language. C++ programming language has been used. I think that is clear. Compiling happens before the execution. Before the execution, compiling will take place. Produces a new output file .exe, .tdb, bin, and dmg. That is, I have put executable files or output file depending on different type of platforms. I think dmg is for the Apple platform, right? So deb and bin files that are for Linux platform, and exe is for Windows. It will produce a new file, right? If you have any compiling. Programs run much faster during the runtime or execution because no conversion needed during runtime. So by the time the program is functioning, there is no conversion. So what happens is, if you compare a compiled program with the interpreted programming language, or if you compile program and interpreted program, compiled programs run much faster than interpreted programs, right? Compiled programs run much faster than interpreted programs, right? That is how it will work. So programs run much faster. Compiled programs run fast. So comparatively, we are speaking, then consumes more disk space because it creates new files. Your source file will also be there. Now, notepad file, when you're creating a Java file, it is taking 2 or 3 KB, that's all. But when you're creating an actual project in NetBeans, maybe a huge one, like a lot of libraries, a lot of class, a lot of image files, icons, database connections, a lot of things you are adding. Let's say it is taking about 2 GB. Your project file is 2 GB. Then when you compile it and when you produce the new file, which is to be given to the client or to the person, let's say that is 3 GB. So 2 GB your project file, source file, plus the newly generated file 3 GB, altogether in the hard drive around 5 GB you are spending for that. When you are compiling, new files are getting created and disk space will be taken for that. It is not a huge problem these days because hard disks are available in terabytes these days. So people usually having around at least 500 gigabytes, or they're having 1 TB, 2 TB hard drives. So it's not a very big deal, but that's the reality, okay? Because it consumes more disk space. Reason is new file is getting created. New files are getting created. Harida, right? So I think you understood that part. Then examples for compiled type of program languages. I have mentioned few. C, Pascal, Visual Basic 6, the old one, okay? Visual Basic 6. Because .NET, Visual Basic .NET, it has a different type of execution. When I'm teaching how Java programs are functioning, I will explain you that, right? So Java runtime environment and all, I'll explain you. So don't get confused. For the time being, remember, C, Pascal, Visual Basic 6, these type of programming languages are, these languages are what do you call? They are compiled type of programming languages, right? Okay, now let's move on to the interpreted type of language. interpreted or interpreter, if you take, converts the source code instructions into machine code during the execution of the program. I have been telling this on many times. By the time the program is functioning, it is getting converted into machine code. So by the time the program is functioning, there is a conversion happening, source code to binary happening. So there is a delay. So therefore, programs will run a little bit slowly. Okay. Does not produce a new output file. Source code itself executed. Last week, I created a JavaScript file. You can remember the JavaScript file itself I was executing inside the web browser. It is functioning fine. When you type two numbers and click a button, it is producing the output. Saves disk space because, you know, source code itself getting executed. No new file is getting created. Therefore, it is much convenient. Okay, much convenient. The next part. Programs run slower compared to compiled programs. As I told you, compiled programs have nothing to convert by the time they are running or they are executing, because before executing, we are converting everything to binary. Interpreted programs, during the execution, you need to convert them into binary. So therefore, during the runtime, conversion is there. So programs run slower compared to compiled programs. That is also there. Then finally, you have the examples. Basic stands for beginners all-purpose symbolic instruction code. It's a all type of language. GW Basic, you can search, you can download, even you can practice. It's like pseudocode, you can write the codes. GW Basic. Then Python, you have PHP, these type of programming languages, even JavaScript. I didn't put that, JavaScript. All these types of programming languages are coming under interpreted type of programming or interpreters, right? So that is about that. Nice. That's the end of that particular slide. Okay, let's pause the recording for a while.